Guys, this is video 8.1 on our new unit dealing with stoichiometry, something that I have mentioned several times before. This is unit 8, and it's going to take us right up before our quarter 2 test, which will be in a couple of weeks. We'll talk more about it in class. So this unit will be about a week and a half or so. About January 11th is when you want to try to wrap this up by. The good news is this is kind of a review with a new twist on what we've already learned. So we've learned about the mole back in Unit 3. It's been a little while, but we're going to come back and review. You just reviewed that. It's dealing with naming and it's dealing with reactions and kind of putting it all into one. So we're going to get a lot of practice of things we've already done and come back to hopefully master that. So this video, like I said, is going to be the first one. You guys should have already done the review worksheet that's not only dealing with just Unit 3, but it's Unit 3 and it's Unit 5, 6, and 7 as well. So it's kind of putting all of that together. This is note video 8.1, dealing with mole ratios. So the first question, while I'm getting to the page, which is page 4, first question you want to ask yourself, or I want to ask you guys, is what's a ratio? We've talked about ratios before, so this is nothing new for us. So if you think back, one word can define what a ratio is. So the word I want you guys to think is just a comparison. Okay. So, oh, that is terrible handwriting. Comparison. So what we're going to do here is we're just going to compare the different moles, amount of moles from a chemical reaction of each substance. Super easy, guys. Do not make this harder than it needs to be. This whole process dealing with stoichiometry will get more difficult as we go further into the unit. So right now we're going to take it piece by piece like we always do. So just keep it simple, all right? So stoichiometry in general, guys, reaction stoichiometry is what that talks about. What it really is the mass relationships between reactants and products in a chemical reaction. So we as chemists try to take a reaction where we know kind of what's happening, but we want to actually, in real life be able to go from a certain amount of reactant material to product material. So we're looking at how, well, if I have this much mass to start with, how much could I produce? Or if I want to produce, 2 kilograms worth of final product, well, how much do I need to start with? Okay, and this is where it's all important. This is what we've been building up to. And then as we go into, semester 2, we're going to start kind of putting it into real life application, okay? So the mole ratio is really where that starts from, and that is determined from a balanced equation, okay? So this is why we've done things the way we've done them over the last couple of months, is to build up to this. So here's our example reaction, and this reaction, guys, we're going to actually use throughout the note series. So when I say refer back to the reaction, this is the reaction we're talking about, and we'll rewrite it, okay? So actually, I don't want to do that, so if you just did that, I apologize. You can use a different color for this. Mole ratios, guys, we're just going to compare all the different substances to one another using their number of moles. So if you think back, review with our reactions unit, the coefficients out in front represent how many moles of a substance, okay? We use moles in chemistry as our counting, right? As our counting unit, some large number, right? If you remember, well, what does 1 mole equal? 1 mole, if you think back to our mole roadmap, you could have mass over here, go into mole in the middle, and then it also relates to particles, okay? And we can go back and forth between those. So now we're going to really be focused in this unit, guys, dealing with these right here, mass and moles, going back and forth between them. So what we got to do first here with mole ratios is just compare every substance to one another. It's that simple. So what I tend to do early on, until you guys kind of get used to this, is I encourage my students to say, okay, draw lines from one substance to every other substance. So aluminum oxide here, we're going to compare that to aluminum. We're also going to compare aluminum oxide in a different ratio to oxygen. Okay, so notice how aluminum oxide has been compared to each of our products. So then we also need to compare products to one another. So we're just going to go through and kind of show the different scenarios where we're doing different comparisons. So how this would look, if I was going to write the mole ratio out, is I would say I have 2 moles. Remember, MOL, guys, is just the abbreviation that I use for mole, and you'll see it all throughout and on your Regents exam and stuff. 2 moles of aluminum oxide are being compared to 4 moles of aluminum. So when we're asked to write just a mole ratio, guys, that's it right there. Do not simplify them. When you start applying them and doing mole-to-mole problems and gram-to-gram problems like we're going to do throughout this whole unit, that's when you can reduce them down when you get into a T-chart. But for now, if you're asked to just write the mole ratio, keep it like you see it right here. Don't reduce it down. The other thing, on the flip side is, we could also have written this as 4 moles of aluminum compared to 2 moles of aluminum oxide. Guys, it doesn't matter what order you put them in. What will determine which one's on the top and which one's on the bottom is when you apply it to an actual problem like we will do in the upcoming videos, depending on what you were given at your starting and where you want to go at your endpoint. So this right here, these two are essentially the same ratio. You don't have to write them both ways. Just one way will be good enough. Okay. The only way you'd have to write it a specific way is if I said, hey, compare aluminum oxide to aluminum, or compare oxygen to aluminum oxide. So be on the lookout for those types of questions that may come your way, because if you don't do it exactly how they ask you to, that's where you could lose points. So just again, answer the question that's being asked. Don't assume you know what it's asking. But for our purposes here in this problem and the you try problem that you guys are going to try in just a second, just writing the ratio down between them is all you need to do. So my next one, so if I kind of cross that out, I've I've accounted for aluminum oxide to aluminum. My next one is I'm going to say 2 moles of aluminum oxide compared to 3 moles of oxygen. So that's this top red line. That's been accounted for. And my last one here is going to be 4 moles of aluminum compared to 3 moles of oxygen. That's it. So for this example, guys, there would only be 3 different ratios. Now we could flip them, so you could essentially have 6 different ratios, but 3 unique ones where you're comparing the substances. Pause the video. I want you guys to go through and try both of these. All right, draw your lines to kind of see how many ratios in total, how many unique ones you're going to have to write, and then unpause it and see. I'll go through them and show you how to do it. All right, so if we're going to take a look, I'm just going to start drawing lines to kind of show my different ratios. So silver nitrate would compare to all 3 of those. Then I'm going to move to the next one. Zinc chloride is going to compare to that, and it's going to compare this as well. And then the last unique one is just silver chloride to zinc nitrate over here. So now I'm just going to start writing them down. 2 moles AgNO3 compared to 1 mole of zinc chloride. So that one's crossed out. Next one, 2 moles of silver nitrate compared to 2 moles of silver chloride. That one's gone. 2 moles of silver nitrate again compared to 1 mole of zinc nitrate. Remember, it doesn't matter, guys, if you put parentheses when you around a polyatomic when you only have 1. It's when you have more than 1 you have to have parentheses, but it's just a good habit to put parentheses around it every single time. All right, so those top 3 are done. Next one, I'm going to move on. I got 1 mole of ZnCl2 compared with 2 moles of AgCl. That's this one right there. I've got 1 mole of zinc chloride compared with 1 mole of zinc nitrate. That's this one. And my last one is going to be 2 moles of silver chloride compared with 1 mole of zinc nitrate. All right, it's that simple. So the last one down here, I'm just going to kind of go through it quickly, draw my lines. Okay, there's only going to be 3 in this one, so 2 moles of H2O2 compared to 2 moles of H2O. That's this one. Then I'm going to have 2 moles of H2O2 compared with 1 mole of O2. And my last one is going to be 2 moles of H2O compared with 1 mole of O2. Okay, so that is as simple as it is with mole ratios. Don't make them harder than they need to be. This stoichiometry stuff, guys, will get more challenging as we go along. So that's all I've got for you this time. See you later.